Hello and welcome to our podcast Pager. I'm George Milner.
And I'm Stan Dale.
Tune in to hear us talk with some amazing people about the subjects changing medicine today. Whether due to traffic accidents, strokes or neurological disorders, brain damage is all too common around the world. Amongst a long list of potential consequences are disorders of consciousness, which include the persistent vegetative state. In this case, patients show clear signs of being awake, though no signs of being aware. In a seminal paper in 2006, it was shown that a patient diagnosed as being in a persistent vegetative state did in fact show signs of consciousness following brain imaging. Moreover, they could be communicated with, despite giving no external indication that they were aware. Having published that paper in 2006, our guest today has been at the forefront of research into disorders of consciousness, and many more patients in a similar position have been identified. Professor Adrian Owen is a neuroscientist at the Brain and Mind Institute at Western University in Canada, where he leads a lab which investigates brain injury and performance with both neuroimaging and cognitive studies. He is also the author of a best-selling book, Into the Grey Zone. In this episode, we discuss how it is possible to communicate with patients previously thought to be unconscious. We discuss our understanding of brain injury and ethical questions that arise in this field as science pushes forwards. So, Professor Owen, welcome. Thanks so much for joining me today.
Thanks very much for having me on.
So I'd like to start off, if I may, with what seems like a rather difficult question, but it's going to form a basis for a lot of our conversation, which is how can we define consciousness?
Well, clinically, we think of consciousness in actually two separate ways. We think of it in terms of wakefulness and in terms of awareness. So wakefulness is literally whether your eyes are open, whether you're awake, and that's one form of consciousness. The other, of course, is awareness, because you can have eyes open, you can be awake, but actually unaware. And by awareness, I mean aware of who you are and where you are and the situation you're in. So we tend to think about consciousness in these two ways, and that's how we measure it.
And presumably this isn't black and white. There's a sliding scale between unconscious and conscious.
It certainly is, yes. And in fact, there's a condition that we study. It's known as the minimally conscious state. I mean, it's not clear whether that is a condition where people are fully conscious some of the time and fully unconscious some of the time, or whether they're somewhere in between all of the time. Similarly, we all go to sleep every night. And if you think about it, you'll realize that you have various states of consciousness as you're falling asleep. There's that period when you're sort of drowsy, you're half there and half not there, if you like. And again, that's another different level, if you like, of consciousness.
So moving on to some of the work that your lab does in Canada, why does this definition of consciousness matter for people diagnosed as being in a persistent vegetative state?
Well, up until, I guess, about 15 years ago now, patients who were diagnosed as being in a vegetative state were often described as awake but unaware. And again, this speaks to these two types of consciousness in the clinical literature. And the idea was that because these patients will often open their eyes and sort of look around the room in a rather sort of roving sense, they'll blink, they'll actually go to sleep, and when they go to sleep, they'll close their eyes. There was never any doubt that they were awake, but they never make any form of response to any form of external stimulation. So if you ask them to look at the clock on the wall, they won't do it. If you ask them to squeeze your hand, they won't do it, or blink their eyes. And this was always taken as evidence that they lack awareness, hence the description, wakefulness without awareness. So it was just generally assumed they were in some kind of zombie state, I guess. And what we've shown over the last decade or so is that many of these patients aren't in that situation at all. Now, it's true they can't respond. They can't respond to any form of external stimulation, but nevertheless, some of these patients are actually aware. They're just unable to show us that they are aware.
So this could perhaps be described as the grey zone, which makes up the title of your recent book. So what causes people to enter this state in particular?
That's a great question. Yeah, I mean, these grey zone states, as I refer to them, are caused by all sorts of different situations. And in some ways, that's what causes us so much difficulty. So I mean, there are so-called traumatic brain injuries, and the cases that we see here are most typically victims of road traffic accidents, people who've been hit by cars or who are in cars when the car has an accident, but also people who've been assaulted, hit over the head with a baseball bat or something like that. That's a traumatic brain injury where the brain receives a physical insult from the outside of the head, if you like. But there's also many other ways that you can end up in a vegetative state, and these are the so-called non-traumatic brain injuries. And these can often occur after, say, cardiac arrest, where the heart stops, blood stops being delivered to the brain is therefore starved of oxygen, and you have what's called a non-traumatic brain injury, an anoxia or a lack of oxygen causing damage to the brain. It can also happen in some situations that people don't often think about. So, recently we've seen some patients who have been involved in avalanches, for example, buried under snow for either minutes, sometimes hours. Sometimes these people can survive, but throughout that period, the brain has been starved of oxygen, and there's been substantial brain damage, enough to render the patient in one of these grey zone states, either minimally conscious or vegetative.
This perhaps explains why people could enter these states, but over 1 million people come to A&E in the UK with head injuries each year. A lot of people don't end up in this state from seemingly similar conditions. In road traffic accidents, lots of people will end up very tragically being killed by such accidents. So do we know what in particular drives people to enter this state?
Yeah, well, we have some ideas. I mean, in some ways, what you're asking is the question that we really want to know the answer to. Why do these patients end up like this? Because that's the first step in trying to reverse the process or bring them out of that condition, is knowing how they got in there in the first place. And, we're making some progress here. I mean, there's an area of the brain deep inside the brain known as the thalamus, and this projects or connects to many areas of the cerebral cortex. So it's extremely important. In some ways, you can think of it as being a sort of a relay station through which a lot of the information in the brain passes. And it does seem to be the case that many of these patients have damage that has affected the thalamus. And I think the reason why that's important is because a relatively small amount of brain damage can have a really quite devastating effect, because the thalamus is so central to many of the brain's functions. Whereas, for example, if the damage only affected a part of the outside of the brain, one area of cortex, perhaps the part of your brain that's involved in recognizing faces, for example, then you might be lucky enough, if I can put it that way, to not end up in a catastrophic situation like the vegetative state, but have, I mean this in relative terms, a more minor condition like a failure to recognize faces. So I think it is to do with where the damage occurs. We know that, for example, in traumatic brain injuries, particularly those that involve high velocity impacts, as would be the case in many car accidents, this area of the brain, in the base and right in the center of the brain, can be subject to so-called shearing forces. The forces as the brain gets bashed around inside the skull, it can shear areas in the base of the brain, and this can lead to this rather catastrophic, but perhaps relatively specific type of damage in areas like the thalamus.
And what proportion of people in this state have you detected signs of consciousness in, out of the people that you've looked at?
Yeah, so it's close to 20%. And now, it's not just us. We were the first to do this in 2006, but actually many centres now use the techniques that we developed to try and look for signs of awareness in their vegetative patients. And there was a large review came out a couple of years ago, completely independently of my lab. That it was a meta-analysis, in fact, that looked at many studies, and there were more than 1,000 patients in the analysis, and it showed again that about 20% of them, so 1 in 5 patients who appear to be completely not there, completely unaware. In fact, when you probe them carefully, when you give them the sorts of brain imaging investigations that we've developed, you can show, in fact, they have some form of residual awareness.
So looking at such investigations, how can you determine people's consciousness in these states then? What sort of techniques are you using?
Well, so up until 2006, the way this was done clinically was, you would ask a patient to squeeze your hand if you can hear me, or follow this ball in front of your face with your eyes, or look this way, or look that way. And as I said previously, often patients would not be able to do this, and it was assumed that, well, if they were aware, they would do it. So the fact that they're not doing it must mean that they're unaware. But it turns out this was a classic case of absence of evidence not being evidence of absence. It was simply an incorrect conclusion. And we sort of joined the dots, I guess, around 2005, 2006, and thought, well, what if it's the case that some of these patients are aware, they are in there, but they simply can't do anything motorically with their body. They can't move. If that is the case, they would appear to be unaware because they're non-responsive, but there must be a way of getting to them. So we developed a technique where we used fMRI, or functional magnetic resonance imaging. We put a patient into the scanner, and our reasoning was, well, maybe this patient can think things. She may not be able to actually perform actions, but perhaps she can think actions. And at that point, we were really coming to the stage that brain imaging was getting quite good at sort of mapping certain things. So, for example, imagining waving your arms around. If I ask you to do that, then an area of your brain right on the top called the premotor cortex will light up in the scanner. And the reason that happens is because this part of the brain is involved in preparing sequences of movements. It's not the part of the brain that actually helps you make the movements, but it's the part in preparing those movements. And if you imagine or think about making movements, your brain sort of prepares to do that. It's getting ready.
And that's quite a consistent response shown amongst everybody.
It's extremely, extremely consistent, and it's a very powerful response. You can pick it up in an individual people almost all of the time. It's extremely rare that somebody doesn't activate their brain when they do this. So we had this patient in 2006. We put her into the scanner. We had to come up with a way of sort of getting her to easily imagine waving her arms around. So I said, well, why don't you imagine playing a game of tennis? Because, that's a game that you can play tennis in many different ways, but you do have to wave your arms around. And that's all we were really trying to get at, a sort of simple way of somebody would understand. And as soon as we asked the patient to do this part of her brain, the premotor cortex sort of sprang to life. And we thought, well, that's pretty amazing. Of course, like all scientific experiments, you want to replicate it. And when we said to her, now stop imagining playing tennis, activity in this area disappeared. And then we said, okay, start imagine playing tennis again. And again, activity started. So I like to think of it as sort of an analogy. It's as if we said to her, raise your left hand now, and she did it. And then we said, okay, put your hand down, and she did it, and raise your left hand, and so on and so forth. And, if somebody did that a number of times successfully, I think all of us would accept that person must be aware that they're obeying the command. They're doing what I asked them to do. We just did exactly the same thing, but with the patient's brain rather than with her arm, assuming, as was correct, it turns out that she was just completely immobile, incapable of producing any of those movements.
I'm just thinking, this must be dependent on patients actually having some sort of intact sensory function, so you can communicate with their cortex and with their brain to do this. What about for patients who have perhaps suffered damage to these systems? Could they be deemed to be unconscious, whereas in fact they weren't?
Yes, and that's a really excellent question. And this is the reason why we're extremely careful about using our methods to conclude that a patient is not aware. I mean, we generally don't do that because, imagine a patient was deaf. They could have been rendered incapable of processing any auditory signals by their accident. If I were to put them in the scanner and say, imagine playing tennis, they're obviously not going to do that because they don't hear the instruction. Or, maybe their ability to understand the English language has been impaired and they can't understand what we're asking them to do. Again, they wouldn't imagine playing tennis, but that doesn't mean they're not aware. So generally, we don't conclude anything from negative results. We just say, well, we couldn't conclude any more than we knew before. On the other hand, the flip side of that argument is an extremely strong one, in the sense that if somebody does imagine playing tennis, you can conclude not only that, well, they can think an action, but they can understand spoken English because they heard the instruction and they responded to it. Similarly, they can obviously hear. And in our sort of academic arguments, we've gone much further than that because, of course, it means people can do a lot more. I mean, it means that some aspects of your short-term memory must be intact. If I tell you to imagine playing tennis now, if you have no short-term memory, you're going to immediately forget the instructions. So the fact that several minutes later the patient does it in the scanner also means that their memory or parts of their memory are intact. And you can build this up. And if you think about all the things that you actually have to be able to do to produce a response like imagining playing tennis in response to the command, it's quite a lot of stuff, to be honest, and it's more or less inevitable that person's sort of inner mental world must be rather like ours.
But moving on from the amazing thing in which we can actually look at people's awareness and look at that short-term memory, we can ask more questions to patients, can't we, in these situations?
Yes, well, of course, I mean, it's a relatively small step. Once you've shown that they're aware, it's a relatively small step to use this same method to actually communicate with them. And we did this first, I guess, nearly 10 years ago now, where we had a patient and we said, well, okay, we know that you can hear us because you're imagining playing tennis when we ask. We're going to ask you some questions. And if the answer is yes, imagine playing tennis. And if the answer is no, do something else. And in that case, we asked the patient to think about moving from room to room in their house because, again, this is another sort of mental action, if you like, that produces a very specific pattern of activity in the brain that's rather similar across individuals and is really quite reliable. It's what psychologists refer to as spatial navigation, our ability to imagine ourselves moving from one location to another. And we said to this patient, well, play tennis if the answer is yes. Think about moving through your house if the answer is no. And in that way, even though despite the fact he'd been repeatedly diagnosed as being vegetative for 5 years in that case, he was able to answer yes and no questions. And that really opened the door to us being able to communicate regularly with some of these patients.
And perhaps, is it possible that patients are moving in between states of consciousness? That actually we could measure their consciousness one day and it would show us one thing, and then the next day or later in the day or perhaps a month later, it might be something completely different.
Yeah, so that definitely happens. I mean, clinically, what we do is we repeat everything twice. I mean, ideally, we would do it much more often than that, but we do it on 2 separate days. So we'll bring the patient in and we'll scan them. And if we see nothing, we'll bring them back 2 days later and scan them again. It's precisely for the reasons that you've just suggested that, some days, particularly patients who are in the so-called minimally conscious state, sometimes they'll be responsive and sometimes they won't. We don't know exactly why that is, whether that condition is a bit like, that going to sleep that we all have, drowsing, nodding off, in the late evening when we're not quite awake and we're not quite asleep. Maybe it's a bit like that. And sometimes, they are aware enough to be able to produce responses and sometimes they're not. We don't know. But it's certainly the case that patients can behave very differently on different occasions. And that's why it's so important to give them more than one chance to respond.
And I guess a question that many people will be thinking of here is, if we've found out miraculously that somebody is in fact aware in this state, then what proportion of people can, from this position, make a recovery? And I'm not necessarily saying a full recovery, but a recovery to some ability, for example, to move or to communicate.
Yeah, that's another good question. I mean, we tend to not use the word recovery for, again, exactly the reasons you've alluded to, which is that when I say recovery, people tend to think, gone back to university or, back on the golf course. And that, to be honest, almost never happens. I've seen it once or twice in my career where a patient has gone from apparently being in a vegetative state to within the course of a year or so. In one case, the patient had gone back to university. But this is very rare. Recovery is usually measured in rather sort of much smaller increments. So recovery, say from the vegetative state to the minimally conscious state, would mean you go from a condition in which you are producing no responses at all to a condition in which sometimes you can produce some physical response to indicate that you have some awareness, but it's not so good that you could just turn that into a regular form of communication, speak to people, squeeze your hand for a yes or a no. You'd be beyond the minimally conscious state in that case. So it's not uncommon for patients to move between these different conditions, but to go all the way from sort of one end of the spectrum, if you like, to the other is extremely rare. And as I said, I've only seen it once or twice in my career.
And perhaps maybe looking further into the future, do we have any insights into how perhaps patients could move further up? Because, I'm thinking here that from an unconscious state to a minimally conscious state could be seen as some sort of stepping stone towards a conscious state. Do we have any insights from the differences between these two different patient groups?
So to answer your sort of the second part of your question first, no, we don't. We actually have no idea. And I suspect there really isn't any difference at all in terms of the sort of specificity of exactly what's gone on in the brain. I don't think, there's something very specific and extra that happens to make you vegetative state. I think it's a continuum, and there are certainly patients who are extremely similar when you see them in the clinic, and one of them might just about have all the sort of characteristics of a vegetative state. The other may have sort of just crossed the line and be able to indicate some level of awareness. But in fact, clinically, they look almost identical. So I suspect it's just a matter of degrees that, some patients, the damage is just so severe that they're right down there at the bottom, the end, that they show no evidence of awareness, and other patients are slightly further along in that continuum.
And I guess we shouldn't be surprised, given actually 20% is quite a large number. We shouldn't be surprised that there isn't one switch that's been almost activated.
Exactly, and of course these patients are really different. Of these 20%, one day one of them I'll see will have been involved in a so-called near drowning accident. They'll have been underwater for too long without oxygen reaching their brain, and the next person may have been assaulted and hit over the head with a piece of wood. So it doesn't really make sense that they've had the same brain damage. There's something really quite different has happened in both those cases, but they've nevertheless ended up in the same situation.
So this all leads on to the question of what can we do with this information then?
Yeah, well, we're making really good progress. And I always make, I'm very often asked the question, well, it's great that you can find these patients, but what are you going to do about it, right? And people have been saying that to me for 20 years now. And, I'm very, very keen to point out that you have to make these small steps. I mean, the only way, so-called cures or therapies and these sort of, therapeutic interventions, that they don't just come out of nowhere. People don't suddenly wake up one day and say, I've got a cure for the vegetative state. It comes through a sort of gradual process of understanding exactly what's wrong with these patients, seeing more and more of these patients and sort of characterizing their injuries and which ones recover and why it might be that they recover and these sorts of things. So in that sense, we're making a huge amount of progress. I mean, up 20 years ago, no one believed any of these patients have awareness. Now we know there's a subset of about 20% who do. And we can and we do look at those people rather sort of specifically and say, so what is it that's different about those patients than everybody else? And it turns out that, again, it's probably damage to the thalamus. They have some kind of we often call this a disconnection syndrome, so that it's not so much about the damage to the area of the brain in question. It's that connectivity between different brain areas has been affected, so those brain areas can't communicate effectively with one another. And one of the patients we systematically studied over a couple of years recently, we showed that it was a projection from the thalamus to the motor cortex, the part of your brain that produces movements, that was impaired. That's where the damage was in that case. Now, knowing that, you can then start to think about, well, what could we do to, quotes, fix that problem? I don't have a complete answer for you right now, but I can tell you that a number of centers are looking into things like so-called deep brain stimulation, where electrodes are placed deep in the brain. And of course, you can't just sort of go around willy-nilly poking around with your electrodes in a patient's brain hoping you'll hit the spot. You've got to do this in a very sort of guided and precise way, and we now know that the thalamus is where we should be looking, and this is a fairly small brain structure, and it's probably a nucleus within the thalamus is actually where we need to go with things like deep brain stimulation. But we're getting there, and we are starting to talk about trying therapeutic trials using these types of surgery in some of these patients to literally try and wake them up or sort of jolt them into a higher state of awareness than they are currently in.
And could these insights be used to improve the treatment of patients in these conditions? Because after all, these patients can respond to stimuli in their surroundings. They can presumably still feel pleasure from activities around them as well.
Yeah, so that's actually the other answer to your previous question that I often give. I mean, people say, well, what can you do for these patients? And actually, we do a lot for these patients because we can ask them questions that make them more comfortable. Now, when these patients do recover, one of the things they typically say is, the worst part of the whole experience of being aware was having no control over their lives, having no control over what music they listen to, what TV what TV programs they're put in front of, how warm the room is, what time the lights go out at night. These sort of simple things that we all take for granted. That's about your autonomy. That's about your ability to personally control the world around you. And that's the thing that these patients in my experience, most often remark upon. It was that complete lack of any control over anything going on around them that was so frustrating. So the techniques that we already have in place, can address that issue. It's not at the moment, it's not a sort of an everyday thing. We can't tune in every day with these patients and ask them about their wants and needs all the time, but we can certainly do it at a sort of the level of saying, well, is there a type of music you'd prefer to listen to now? And again, it's a sort of little anecdote that I told in my book about the patient who recovered after some years in a vegetative state, and her mother had been playing her the same Celine Dion album over and over again. And the first thing she said when she was able to communicate was, if I ever hear that Celine Dion album again, I'll kill you. And, it's joking aside, I mean, it makes a really important point that many of these patients survive for decades in this situation. And the chances are, 2 decades on, you probably don't want to listen to the music that you were listening to 2 decades ago. But that's not how this works typically in these patients, because time stays still. People continue to expose them to the sorts of material that they used to like, because that's the only information they've got available to them. And we can change that. We can update their lifestyle, if you like. It's a small thing, but it turns out that it can be very important to some of these patients.
And perhaps a more theoretical question. We've heard a lot in the media recently about brain-computer interfaces and things like that. Could, perhaps a long way down the line, we allow these patients to actually influence the outside world?
Yeah, I mean, I don't think it is a long way off, to be honest. I mean, in some ways, the technique we developed using fMRI, is a brain-computer interface. I mean, it's a way of the person interacting with the outside world using a piece of technology. It turns out it's extremely expensive, not at all portable, and certainly not the sort of thing that, one could use on a sort of day-to-day basis. So, we and many other groups around the world are working on other forms of BCI or brain computer interface using things like electroencephalography or EEG. Another method known as near infrared spectroscopy is also looking quite promising in this regard. And these are both much more portable and actually more cost effective than something like MRI. But it's difficult, and it's proving to be more difficult than I had hoped, to be honest. And partly that's because many of these techniques work very well in healthy people. So we have quite good EEG methods for, moving a cursor around a screen just by sort of thinking about it or by thinking certain thoughts using electroencephalography. But it's a much, much bigger problem to make it work in a patient. And, partly that's because they have brain damage. They don't have the same cognitive resources that perhaps you or I have. Also, many of these things involve very precise modeling of the human brain. I mean, to be able to take the electrical output of the brain and turn it into an action, moving a cursor around a screen, is computationally very, very complex, but also it requires that you make various assumptions, for example, about the shape of the brain to understand where these signals are coming from. And if you've been hit over the head with a plank of wood, your brain is going to be a different shape than the norm. So you end up having to sort of almost build a brain-computer interface for each patient, which then makes it extremely laborious task. And I don't think there have been a few modest successes, but we are a long way off having patients who are completely non-responsive, being able to interact with the outside world.
So, going into the future, as our techniques for looking at brain activity become more and more precise, are we going to be able to glean more pieces of information from the brain? Because just looking at, say, motor activity or premotor cortex activity on and off seems to be reasonably crude in the scheme of things.
Yes, it's true. It is. And absolutely, we are working on other methods of decoding much more complex aspects of brain function, as are many other groups. And there have been papers in the last couple of years showing things like you can decode from brain activity alone what picture a person is looking at, for example, if given a number of pictures. We've been doing a study to try and decode what music somebody is either listening to or imagining. So it's almost, you take the brain signals coming out of the brain and you sort of deduce from that combination of signals what it is that's going into the sensory system, into the eyes or into the ears, or indeed what somebody is just imagining. At the moment, I would say those things are largely constrained to a sort of subset of items. So we're pretty much at the point where we can decode, say, which picture somebody is looking at of a series of pictures. And that series can actually be quite large, but we're not quite at the stage of just being able to say, this is what somebody is looking at, with no knowledge of, a sort of subset of possible pictures. But that'll come in time, I'm sure.
So perhaps a more difficult question, given the heterogeneity between different people's brains, how precise do you think we'll be able to get in terms of looking at brain activity?
I think we'll be able to get very precise. I mean, people tend to think that brains are more different than they are, and brains really are like faces. Everyone is different, but they all have sort of common characteristics. Mostly there are two eyes, a nose, a mouth, and hair, and so on and so forth. So, and brains are like that. That most of our, the sort of important parts of our brain are in the roughly the same spot. There's obviously a little bit of variability, but actually most of these new techniques don't really rely on brains being anatomically identical anyway. You're looking at sort of brain functions, and to some extent, if I'm trying to decode, what, say, picture you're looking at, your brain does not need to be identical to my brain for me to be able to do that. It's simply the pattern of activity of different brain regions that we're using in the decoder.
And perhaps moving on to, we've already touched upon some of the ethical questions surrounding this. One of them is cost of using these neuroimaging techniques. But another question, actually, which you've brought up yourself and have responded to before, is whether actually there are a lot of nuances behind this, and whether we could be bringing perhaps false hope to patients' families if there is actually only a small chance of recovery in these states.
Well, I'm always very interested by it. And I think it must just be a sort of a knee-jerk reaction that people have, either when they haven't really experienced what it's like for these families, or simply because that's our sort of default response. Because I can say it's mostly not true. And we've dealt with many, many hundreds of families over the years, and we've given them all sorts of information, sometimes good, sometimes bad. And I would say mostly, almost without exception, that information is accepted as positively, in the sense that they know more about the patient. And, it's not the fact that people immediately jump to the conclusion and say, OK, well, if my loved one is conscious or has some level of awareness, they're going to recover. It's often the next question they ask, does this mean they have a better chance of recovery? But these things don't automatically go hand in hand. And I think by the time we see patients, and often, they've been months or even years in their conditions, that the family have come to terms with the fact that it's extremely unlikely there's going to be any significant recovery. So, in that context, they are often extremely happy to sort of get this additional new information about what it's like to be the patient.
And perhaps on the flip side, if we do end up using these techniques to look at the brains of people who have much more recently been involved in accidents, perhaps for diagnostic or prognostic reasons, could you see people's responses being slightly different, or do you think people will respond as positively?
Well, when an accident or an injury has been more recent, the chances of recovery are higher. So the longer you go on in one of these conditions, the lower the chance that you'll have any significant recovery. But we're starting to work now in the acute phase. So most of the patients we've seen over the last 2 decades or so have been so-called chronic patients. They've been like that, and they've been stable and unchanging over many years. But typically in the first few days after brain injury, there are many, many changes. And that's where there's maximal chance, if you like, of some sort of recovery. And I think that's to be honest, it's a whole different ballgame And it's a very new ball game. We have only a little bit of information on this. But I feel quite confident that we are going to be able to improve prognostication in, for example, the intensive care unit. Some of these techniques we've developed, I'm sure, are going to be able to tell us with more confidence than we can do with the existing clinical methods which patients are going to go on and do well and which patients aren't going to go on and do well. And obviously that's extremely important, because this is where life and death decisions are made every day. People are, quote, pulling the plug when they think there's no chance of a significant recovery. And I think we may be able to change the information upon which decisions like that are typically made.
And do you think in the past, actually patients with traumatic brain injury have not been recognised to be in this conscious state, and actually the healthcare professionals have given up on them in these cases, and actually they've been left to die?
Well, you used the word nuanced earlier, and it is a very sort of nuanced issue, this, in that I don't at all want to, give the impression that I think people have been either making mistakes or people have been letting people die unnecessarily. I mean, this is a very, very complicated situation, and obviously there's an awful lot of stress involved and not much information. Every patient is different, and in those early stages, it really can be, the people are, literally at the border between life and death. And one way of thinking about it is to sort of stop thinking, well, is this the difference between, being in a coma or having had a traumatic brain injury and, going back to school, going back to university, living a, long and happy life? Often that's not really what we're talking about here. We're talking about, does this person have the capacity to survive at all? And if they do survive, what's the quality of their life going to be like? And sometimes we talk about the so-called window of opportunity, which is the period between the injury and the point at which, say, a patient emerges from coma or comes out of the intensive care unit and is in, say, a vegetative state. And, many people would prefer that not to happen. And that's what we mean by the window of opportunity. There's a time when it is possible to sort of let the person go by, quotes, pulling the plug. Some people think that is preferable to running the risk of having to care for them for the next 2 decades in a vegetative state. So, I think it's really important to think of it like that, because, if you've had a very severe brain injury that puts you into a coma in the intensive care unit, you're never going to be the same again, or at least it's extremely unlikely that you're going to be the same again. So we're not really talking about letting people die who could have gone on and lived, perfectly healthy, happy lives. Some of them might. There's always that possibility. But it's trying to work out what their future could actually be like. And that's an important factor in trying to determine, whether they would prefer to have been let go early on, or whether they would prefer every effort to be made to keep them alive, whatever the circumstances.
And another sensitive question, now that we can actually communicate with these patients, in general, what is their quality of life like in these positions?
So we don't have a lot of information because we've only managed to communicate with, a handful of patients, and the quality of that communication is fairly rudimentary. But up until now, we've been surprised by, these patients are not, I'm not going to say that they're not as badly off as you would imagine. Of course they are in many respects, but they're perhaps not as unhappy as you might expect them to be. And there's a very good study came out, I think in 2016, a French study that looked at patients who had locked-in syndrome. Now, obviously, so the locked-in syndrome is a condition in which you are perfectly aware, completely aware, but you have a very profound motor disorder. You typically can't move. Some of these patients can, blink an eye or move their eyes to communicate, but basically you're completely immobile. So it's not quite the same as the situation we see often, but it's about as close as you can get, and these patients can at least communicate with us regularly to tell us how they feel. One of the surprising things about that patient group is that they rated their quality of life at about the same as the so-called control group, the people who were healthy. So now many people are surprised by that and say, surely these people must be terribly depressed. They must want to die. They must want to, end everything. And the information that we have suggests that isn't the case. The way I sort of think about this is that, we see this in many, many different walks of life, that people suffer, quite severe injuries or damage to, say, parts of their body other than their brain. And many people go on to live extremely happy and fulfilling lives. For example, people who might have lost their legs or their arms or become blind, these sorts of things. And I'm not saying all these people are happy. Obviously, some are happy and some are not happy. But it isn't the case that for people who lose their legs, they all become terribly depressed and never manage to get their life together. People have tremendous capacity, I think, to recalibrate their lives and find ways of making themselves happy. And I don't think we should presume that something similar can't happen to these patients as well, just because to us, it seems like the ultimate nightmare. And this is something that we would never want to happen to us. And I'm sure they wouldn't have wanted it to happen either. But once in that situation, maybe they find ways to find pleasure, or at least find a positive outlook on life.
Indeed, I think Jonathan Haidt, in his book The Happiness Hypothesis, he talks about almost imagining the best and the worst things that could happen to you. And he says winning the lottery or perhaps becoming a paraplegic. Talks about this kind of massive increase, this euphoria with one and this almost depression initially with the other, and then actually tending back towards this almost set point in happiness, never truly kind of colliding back together, but not necessarily being as far away as we perhaps imagine.
Yeah, I think you have to just go with the evidence that we have, right? You can imagine whatever you like, however bad you think it's going to be, but we have to base our decisions on the evidence that we have, and the evidence that we have suggests that these patients aren't as happy as the rest of us think they might be.
I think that's probably quite a positive message to take into the future of this research. So Professor Owen, thank you so much for talking with me today.
Absolutely, my pleasure. Thanks for having me on again.
Thank you for listening to the Pager podcast. If you've enjoyed it, then head to Spotify or iTunes to hear more.
As ever, we'd love to hear what you think. Do leave us a review on Apple Podcasts if you have a moment, and you can also reach us via our website and our social media pages.